DevOps practitioners, software teams, generally anybody who is adopting Kubernetes or is running container-based applications, has cloud native initiatives, is looking for a path forward for how they can start using Kubernetes. So if you've been using Kubernetes in production, a lot of this stuff will be familiar to you, and it may feel as if you're already doing it, or you may even have additional things that you're doing that are not covered. But this is really just for a broad audience, and hopefully can help describe how we're using Kubernetes in the cloud. As I mentioned, this is going to focus on managed Kubernetes services, specifically in AWS. I'll be talking about the other clouds very lightly, but since my experience and our team experience at Nebulaworks is focused on AWS, that's where a lot of my experience and examples will be derived from. Also, I'll be talking about how we use infrastructure as code to manage our Kubernetes clusters, as well as all other resources in the cloud. So this is a conversation about a little bit about Terraform, a little bit about Kubernetes, a little bit about AWS, and also I'll be covering some concepts about CI, CD1 delivery, and CD2 deployment for container-based applications. And the reason why this talk was developed is to share experiences that we've learned over the past 6 years. Our CEO was a Docker captain initially. We did a production grade container deployment in 2013 using Zookeeper and Docker before there was even Docker Swarm. So we've had a unique experience here where we've seen the evolution of containers over a long period of time. And as you guys may understand, there's been orchestration platforms like Swarm, Mesos, Kubernetes. So over the past few years, there's been radical shifts in this ecosystem, and we've kind of seen Kubernetes take the lead on it. And if you've been paying attention to the news, Docker has been recently acquired by Mirantis. So their play in the marketplace and industry is also shifted. So just kind of keep in mind that all of these technologies are rapidly evolving. And so today I wanted to talk about how you can use a cloud managed service to get you and your team up and running fairly quickly with Kubernetes. Before I jump into the rest of the slides, I wanted to start with the end in mind. So from our perspective, or my peers at Nebulaworks, as well as other teams, I just kind of try to distill down 3 things that we find valuable when using Terraform in the cloud and Kubernetes. First of all, we want to be able to deploy the cluster in a consistent way. And we could do that with Terraform, leveraging modules, reusing code. Second is we want to have ease of management of the cluster and be able to update it transparently. So with managed services, you have the ability for automated updates and upgrades. And I'll go through an example of how, if you are using Terraform AWS and a module that it's called the EKS module, you could find it in the Terraform registry. It's called Terraform EKS module, how you would do an update in AWS with that stack. And also how you can iterate quickly and safely on your container applications with keeping security front of mind. Container security is something that is developed, has been developed over time. And there's a document called the NIST 800-190 that I'll be talking about a little later. That'll be a great reference for people that are trying to figure out the domains in which to secure your container applications. And from our perspective at Nebulaworks, looking at the software development lifecycle of containers as it fits in CI, continuous integration, delivery, and deployment. Generally, when we're trying to secure this process or the lifecycle of developing these applications, we could determine what tests and what gates we should place in this workflow in order to set up the appropriate guardrails for our development teams to iterate safely and to give them more confidence in what they're doing and making sure that they're not doing anything they're not supposed to. So as I mentioned earlier, it's been a roller coaster in the container landscape in the last 6 years with Docker as a runtime, Rocket, LXC before that, Containerd, Runc, Docker Swarm, Mesos, Kubernetes becoming now production grade, And in our opinion, managed Kubernetes services provide teams the ability to provision Kubernetes clusters quickly and easily. So to begin this conversation, I wanted to just discuss at a high level what managed services look like. And I know this is a diagram that was taken from the documentation on AWS. And for a second, I just want to abstract away the fact that this is EKS and kind of talk about what the architecture models are for managed services. So typically you're paying for the control plane. So for EKS and GKE, which is Google's Kubernetes engine, you will have to pay for the control plane. And you'll also pay for the worker nodes that are typically in some sort of auto-scaling group or scale set type of object. So in this case, you're paying for both of those. Typically, the control plane is abstracted away from the user, and you could treat the cluster as you would any other Kubernetes cluster. I remember back a few years back when Kubernetes was first coming out, there was tools like COPS, KubeADM, and just ways to automate the provisioning and bootstrapping of these clusters. And I remember we're in the office at work using Raspberry Pis and KubeADM to bootstrap this stuff, and using servers in the office to do it. And at this point, these services have now become pretty mature. This conversation would have been different about a year ago, or late 2018, 2019. But here's just a high level table I put together where you could see that these different Kubernetes platforms are comparable in many ways. AKS was kind of a laggard, and up until recently, they do have multi-AZ support for their deployments of managed Kubernetes services. And you can see the versions here. AKS is one major version above EKS and GKE, which are very close behind it. So the maturity and development of these tools for these clouds will continue. And at this point, in my opinion, stick to the cloud platform that your team has the most experience with, and begin experimenting with the functionality and features that their Kubernetes managed services provide. So next step here is talking about how we can use infrastructure as code, specifically Terraform, in order to provision and manage our Kubernetes clusters. This is an architecture diagram taken from a project that we built out and deployed into Amazon. And I'm not going to get into too much detail here. I just wanted to describe at a high level that we're using an EKS cluster, multi-AZ deployment. We're deploying Vault, Console, and connecting everything with Console Connect, which is a service mesh functionality. So if we were to do this by hand, it would be very difficult. It would be stressful. It would be a nightmare, especially if we wanted to scale out these deployments many times. So distributed systems in themselves are complex. And in this case, we have an orchestration platform and in this case, 3 other distributed systems where we have Console as a KV and service discovery tool, and then Console acting as the Vault backend. And Vault is just a secret management engine that you can use to place secrets. It has encryption in transit, encryption at rest. So these tools put together are pretty complicated. And the only way that we feel would be reasonable to manage this stuff is with infrastructure as code. And if you're not familiar, infrastructure as code is tooling that allows you to manage and provision resources in cloud platforms with source code. At Nebulaworks, we use Terraform. It's cloud agnostic, and it allows you to provision resources with a declarative language. It's called HCL, or HashiCorp Configuration Language. It's pretty readable. It's easy to write. It's easy to read. And it's declarative, as I just mentioned. Declarative languages are very useful in the fact that we could define the desired state or the desired resources and dependencies that should exist. And the tool, Terraform, will go make that happen in reality. Terraform itself is composed of providers, which is libraries of APIs that can interact with different platforms. So for example, if you're using AWS or Azure or GCE, Google Compute Engine, you have the ability to write your config or write your Terraform, your main.tf file or your Terraform manifest, define resources, and of course, provide the appropriate credentials in the most secure way that you can to be consumed and used by Terraform. you write your manifest, and based on what resources you're defining inside of that manifest, Terraform, with a command called Terraform init, is able to pull down the correct dependencies in order to interact with that provider. So we define what we want, and Terraform will go make sure that it exists. So we're defining the desired state here. Another positive thing for using infrastructure as code to manage Kubernetes clusters is that we can use the source code as the source of truth. We can leverage software development principles and practices that we would apply to other general purpose programming languages to our infrastructure as code. So the rigor that we put into our branching, the standardization around our code etiquette and code review process, even automated testing, our CI, our CD1, all of these principles and concepts can be applied to our infrastructure as code. And this is a shift for operations teams that may have been doing things manually or using maybe just raw scripts, bash scripts, or other types of automation tools to do so. And so this infrastructure as code tooling should be treated like other source code. And just to clarify, Terraform, its strength is in infrastructure scaffolding. So other tools such as Chef and Ansible have a place, and they have a place in in-place configuration management, configuration updates. But Terraform, its strength is being able to deploy the raw underlying resources and even providing the ability to configure and install services for you. So oftentimes I hear the question of what's the difference between Terraform and Chef and Ansible? Terraform is declarative. Terraform is, so I have a question here. So I'm going to go really quick and unmute him here.
Hey,
Matt,
how's it going?
Hey, yeah, go ahead.
So, so do you guys tend to define, I guess, Kubernetes resources? So I know there's like Terraform, an EKS resource in Terraform, right? But the actual Kubernetes resources themselves, so leveraging the Kubernetes provider, do you tend to define those in Terraform, or would you rather have something like Helm do that?
That's a good question. So for some resources, for initial bootstrapping of the cluster, we might want to leverage the Terraform specific resources for Kubernetes. However, we also leverage tools like Helm, like you mentioned, and kubectl. And I think that question is a good one. And I tend to think of it as what's the development lifecycle for each of these different tools. So for Terraform, which I mentioned is raw infrastructure resources, versus Kubernetes objects and resources. So do we want to tightly couple Kubernetes objects with our Terraform deployment? And in my opinion, I think that those are separate life cycles. So if we wanted to develop our Terraform code and be able to iterate on the infrastructure, that shouldn't affect how we are deploying our container-based applications onto Kubernetes. So I think there should be some demarcation or separation of concerns there, where infrastructure as code is used to provision the underlying resources or cluster, and then you use the ecosystem-specific tools like kubectl and Helm to deploy those onto the cluster.
Sweet, thank you.
Sure, thank you for the question. All right, Lynn, I think you're unmuted. You could try to speak, and yeah, I think you're good. What's up?
Hey. So you mentioned that instead of using Chef or Ansible, you can use Terraform to install stuff. So how would I go about doing that with Terraform?
Yeah, so there's a few ways you can do it. What we prefer, so first of all, at Nebulaworks, we are Linux advocates, open source advocates. So we use Linux across the board. And so when we do that, we have the ability to use something called Cloudinit. And Cloudinit is a agnostic tool that allows you to pass in config files, different types of scripts, and run those upon instantiation. So it's a combination of Cloudinit and user data. So we can pass in bash scripts in order to configure the underlying instances that we're provisioning.
Awesome. Thanks, Anthony.
I have a question.
Sure.
Are you guys going to talk or touch base with ECL, or that's going to be a later topic?
That will be a later topic. That is a good question though, and there's a lot of movement in that ecosystem space.
Correct.
So thank you
That's
for the
why I
feedback.
mentioned about it. Yep.
Okay. Cool. Thanks for the questions, everybody. Cool. So I'm going to pick up where I left off here. So next component is the fact that we have desired state management with Terraform. So Terraform, as I said, allows you to define the desired state with your manifest, and it's able to deploy what you want into a cloud platform. So state is the mapping between what your manifest says and what exists in reality. So if you wanted to update your manifest to make changes to live infrastructure, and you made some update, Terraform has the ability to determine what changed and how it would look if you did go ahead and want to deploy or apply those changes. So Terraform has a set of commands that you typically run in order. So initially, if you have a manifest, you would run Terraform init, and then Terraform plan, which is somewhat of a dry run, and then Terraform apply. So you have the ability to update transparently what you're doing. And so when we do approach problems generally for the cloud or leveraging infrastructure as code or Kubernetes, there's a flow that we typically follow, and it's to identify the problem, team and timeline, create the architecture diagram as I showed you before, and then with a loose agile framework, begin to collaborate with the team or the engineering team working on this. So we have the kickoff meeting, we do an initial sprint planning session. All issues are tracked on Kanban boards. No work is untracked. We have releases at the end of every sprint, bi-weekly sprints. And at the end of the timeline in the project, we will be going back to step one, reassessing the architecture and continue to evolve the platform that we're building. This is a high-level sprint overview diagram that was developed for the project that I mentioned earlier with all the lines and all the console vaults and Kubernetes deployment. And generally, if you are a greenfield team here and you're looking to start your initiative into the cloud with Kubernetes, this would be very useful. So I'll walk through quickly what this diagram means from left to right here. So from our perspective, when we did deploy that, there was three logical groupings of tasks that existed in order to accomplish this. So I mentioned the strength of Terraform is the ability to deploy raw infrastructure. So the first sprint here was focused on deploying the VPCs, the EKS clusters, deploying the Vault and console auto-scaling groups, and installing those services on those VMs. So that's the underlying infrastructure that's going to be supporting our applications, supporting our layer 7 routing, our secrets management, and so on. The next step here is after the EKS cluster is provisioned, we'll be using Kubernetes specific or Kubernetes ecosystem tools like Helm, deploying metric server and Elastic Stack for telemetry and monitoring. In this case, we're deploying console as a Helm chart across the Kubernetes cluster, as well as configuring console connect and Envoy in order to have network access control between the Kubernetes clusters and the VMs that we're running in that environment. And then at the end here, we have a validation that our infrastructure was provisioned correctly. So there's different tools that you can do this. And I encourage you to, if you haven't already been testing your infrastructure in an automated way, there's tools like ServerSpec, Chef Inspec, and other methods that you can use to validate that when you do deploy your Kubernetes clusters or you do deploy your infrastructure in AWS, you are doing your due diligence in making sure that it is operating in the manner that you expect it to. And across the top here, we have research, testing, and documentation. We all know that technology shifts so quickly, so we're constantly researching, we're constantly testing all of our branches, all of the new features that we're merging into the mainline, and we're documenting as we go. We want to make it easy for ourselves and other engineers in order to pick up where we left off. If the long-term vision is to have Kubernetes running your workloads for a year or 2 years or 3 years from now, doing the due diligence on the initial platform build, the platform deployments, documenting everything as you go, makes it easier for other engineers that will potentially have to manage this stuff later down the line. So what's the value of using Terraform, really? I could just deploy this thing by hand. And my counter to that, if that was a question that was brought up, would be that if we wanted to support multiple environments, and we wanted to do this manually, it would be very difficult. So in this case, we can use infrastructure as code to segregate the different environments. So in this case, we have dev, stage, and production. This might look different for your organization, but typically the idea is that we want to have the ability to have discrete state and environments to support different business initiatives or IT initiatives, development initiatives, whatever you want to call it. So in dev, you might have automated deploys of your applications to this place. This could be treated as a sandbox to test for your developers to go in and deploy to the cluster. And then staging might be some set of integration tests that go beyond maybe the Kubernetes cluster itself, but maybe for external logging or external shipping to a centralized logging endpoint, or other entities that are going to be involved in making this thing production ready. And then, of course, production to support production workloads. So Terraform provides us the ability to have discrete environments, be able to reuse the code that we write using a concept called modules in Terraform. And if you're not familiar, it's basically like a function where we write functions to abstract away complexity. If we find ourselves copying and pasting code over and over again, and it's a lengthy amount of code, then we can abstract away that complexity by writing an interface or a reference called a module that basically can source, we could source that module from other directories. And I'm not going to get too into detail about how we version and release all of this code, but generally with a module, if I have this K8s platform and dev, stage, or prod, I can reference the module 2 directories back in modules Kubernetes platform with a relative path, or I can use a Git URL. And we use Git URLs and tags to reference stable versions of the code bases that we're developing with Terraform. So this is a quick upgrade scenario if you're using AWS with the EKS Terraform module. There's this feature called cluster autoscaling, which is if you go to GitHub or Google GitHub Kubernetes Autoscaler, you'll see that this functionality will provide the ability, if there's a node that is running deployments or pod, and there's resource constraints that are preventing Kubernetes to schedule to that node, then the cluster autoscaler functionality will then deploy additional nodes in order to compensate for that lack of resources. So this is a prerequisite in this case, that we need to have that cluster autoscaler, because we're going to do some sort of a rolling update here. We basically update the launch configuration to the new versions of the AMIs in our worker nodes. We use kubectl to drain, basically evict the node, all the workloads that are running on the existing nodes. And these workloads will be rescheduled to untainted nodes. And once these nodes are tainted, then the cluster autoscaler will create new nodes. You progressively move through each of the nodes in your autoscaling group or your worker nodes until they're all tainted and all work is rescheduled, and the cluster autoscaler will automatically terminate the nodes for you after sometimes 30 minutes to an hour. And additionally, there's another set. So and this 1 through 7 is discussing how we would update the worker nodes to newer versions of Kubernetes. There's also additional components that are running on top of the Kubernetes cluster, like kubeproxy, your core DNS, the CNI that you're using, or the network that you're using, the overlay network for Kubernetes, and other components that are running on top of Kubernetes that you should also upgrade. So at a snapshot, this is how you can upgrade a cluster using the AWS EKS Terraform module. So AWS EKS being managed by Terraform. This is the upgrade process. If you Google GitHub Kubernetes Autoscaler, that would be a good path to show you how you can use the autoscaler to automatically scale out your nodes in the event that there's insufficient resources for your workloads. So now the conversation is going to shift towards a little bit more about the container software development lifecycle. So this model or this graph, imagine you have a team that is just starting out with containers or Kubernetes. There's a need or a desire to go cloud native, to deploy their cluster in the cloud. And the first step is the initial deployment, and CAS here is container as a service. So in reality, this is really just a Kubernetes managed service. So if we're cloud native, we're deploying Kubernetes with Terraform. There's no standardization around how we're developing containers. There's no requirements, functional requirements of applications or teams. However, we have a cluster running. You may find yourself on this continuum somewhere if you are already using Kubernetes. However, this is kind of a broad continuum to show how a team that is maybe greenfield might see the bigger picture to look at the long-term vision of how they could adopt containers and container orchestration platforms. So the second set here is to focus on the continuous integration and delivery of these container applications. So containers are valuable because they help us standardize on an artifact. And in this case, if we are developing a workflow for developers, we want to have some standardization around branching, some standardization on how we're testing our code. So example, having unit tests or regression tests for the general purpose programming language. And then after that, when we're defining our Docker files, to run linting and then image scanning against the built image to validate that there's no malware being injected and that the developers are doing their due diligence. And then having CI in place for applications, as I mentioned, for the general purpose programming languages, as well as the image creation. And at this point, a team can identify the security domains that they would like to cover. Generally, there's best practices around how we build images, trusting base images from vetted sources, not just from Docker Hub, where you can go and pull down something that somebody wrote and potentially injected malware. And there's many tools, like GitLab CI has integrated image scanning with one of their paid for versions. There's also tools like Twistlock and even open source tools that can help you do image scanning to look at all the layers in your container image to determine if there's any malware in there. So this is just identification of those security domains. So this is a collaboration between the development teams, operations, and security, looking at how developers are building out these workflows and placing, like, of course, prioritizing productivity, however, also wanting to put the appropriate guardrails in place so that there's nobody accidentally does something that they're not supposed to. The next step would be enforcing security best practices. So this is enforcing it. The first step was identification, enforcing them. So this is leveraging tools like the GitLab CI image scanning or Twistlock and placing it in these workflows and making developers go through this process. Also, this is a time when, so we're talking about containers and application pipelines. The first part of this presentation was about infrastructure as code. So generally there's pipelines is, I don't want to get caught up on that nomenclature, but it's really two workflows. So there's an infrastructure team developing infrastructure as code that has their own branching strategy, their standardization on release engineering. And then you have your application teams that are building their applications and containers and maybe dependent on the infrastructure team to provide the platform to support their apps. So at this point, we have parallel workflows. So generally, we want to keep these workflows with a common set of tools. So if you're using a GitLab, something like that, if you can use the same process for project management, like the issue tracking boards, the GitLab CI runners, the image scanning. So if you can consolidate all the functionality that you need into a single tool like that, that would provide higher transparency for other teams that are working together, although in parallel discrete work streams, still working together to accomplish something. And the next one here is end-to-end telemetry. And this is something that should be thought about and developed throughout the process. So it's not like this is something that you do at the end of the day. However, some of the other aspects of developing containers and working with teams to build maturity and adoption with containers are a lot of it is around process. It's around standardization. It's about making sure everybody understands what everybody's doing. So security wants to provide the appropriate guardrails for the developers, but they also want them to be productive in what they're doing. So it's a collection of different initiatives that combined will provide the ability to take advantage of some of the promises of Kubernetes, of Docker, that are so attractive to engineers and teams. And at this point, you can use security policy. There's tools like Open Policy Agent that you can use on top of Kubernetes to control what resources are to be created. There's even tools for Terraform if you're using the enterprise version called Sentinel, or also other policy engines in the cloud that can provide you, the security team or operations teams or administrators, the ability to have even higher levels of governance on your cloud platform, your Kubernetes cluster, and how your teams are building containers. So after all of this, as we move to the top right, our team capabilities grow and we have more business velocity as an outcome. So once people understand the standardization around branching, the common set of tools for security, for the continuous integration aspect, unit testing, all of that stuff, once you have that in place, and developers have a few iterations of moving their code through these workflows, you eventually gain more maturity, your team capabilities go higher, and you can experiment on newer technologies, like someone mentioned Istio. Ecosystem tools that are very new, they're very fresh, and people are trying to understand and figure them out. So now that was kind of the vision of how container adoption can happen. The next slide here is going to be about continuous integration, delivery, and deployment. So typically, if it's one person developing a code base, then they could just write their code, test it on their workstation, write a script to test it for them, and they're good to go. However, typically that's not what's happening. So if you have more than one or two people developing, CI is extremely critical to have. And continuous integration is a bot or a runner that's validating that the engineer did the tests that they were supposed to do. So in this case, since we discussed infrastructure as code and we discussed the general purpose programming languages that we're building into Docker containers, there's going to be two workflows that exist at the same time. And this step is really just validating that the developers or platform engineers are doing their due diligence in testing what they developed. When we're working with teams, at least in Nebulaworks, or when we're working with our clients, we're going through a code review process. We're testing locally, and then we even have internally at Nebulaworks using an open source tool called Atlantis, where we can run plans and applies within our merge request interface to be able to audit and see that the code that we wrote was behaving in the way that we expected it to. And of course, having the approval process there where we have two people review is always enforced. So after continuous integration, which is validation of tests being run, we have CD1, or continuous delivery. And this model might be new to you, it might be very familiar, but in the case for containers, delivery is intended to talk about the delivery of container images. So the common workflow is if we shift left for a second, and I'm developing a Python application or a web server with Flask, and I'm iterating on the features in Python, and I write some unit tests to validate that things are working for some logic that I defined. So that's testing the application source code itself. The next step is to validate that we're doing our due diligence when building our Docker files and our Docker images. Docker files, first of all, we can do linting on those. We can make sure that we're writing them efficiently by not having too many run commands. If we can execute a single run command and build a one layer cache layer at a time versus having like apt install over and over again, those are different layers that need to be built every time. If we can build one, if we could put apt install and then leverage the ampersands to concatenate these different commands together, this will result in a single image layer. So there's some best practices in developing container applications that you can enforce using linters. And once the linting is passed, then we can build the image. So now we have the applications that have been tested, we have the Docker file that's been linted, and we're typically loading in the source code into the container with a volume or with a relative path or amount. And then we could bake the image. So we bake the image, and this could be a component of the continuous integration piece or continuous delivery piece, depending on where you want to draw the line. But the idea is that once you build the image, you need to then leverage an image vulnerability scanning tool to validate that the image is secure and stable. And at this point, if it passes that test, or set of tests that are put into place, then that image could then be placed into a container image registry. So we use, if we are in Amazon, tools like ECR, those are very easy to consume because they're native to the cloud platform. So if we're using EKS, we could use ECR to store all the images or container images that we're using and deploying with Helm or kubectl. And continuous deployment is not always a automated step. And as you can see, we kind of, from the left, so script-based, where it's a single guy on their computer, single guy or gal, and they're testing their stuff. And then the next step is to put some automation in to validate that they tested. And then CD1 or delivery is baking in an artifact similar to compiling a binary, making sure that it's pen tested or something. Once we validate that that artifact is good, we have the ability to place it somewhere to be deployed. So deployment is typically aligned with business initiatives. So in our case, following a loose agile approach, we deploy at the end of every sprint. So deployment is continuous deployment is the ability to deploy things. And in this case, there's an example here that says, supporting modern deployment methods, blue, green, and canary. These are very mature methods. So this is just an example of perfect world type scenarios where if we do have all these tools functional, we have very mature teams, we could then entertain these different paradigms of deployment. But generally, at this point, I just want to draw the distinction between delivery and deployment, where delivery is providing the ability to deploy, and then the continuous deployment is actually deploying it. And this is so at Nebulaworks, we practice trunk-based development. And if you're not familiar with trunk, there was a presentation done by one of my peers that was around trunk-based development. And it is a branching methodology in Git that favors having a stable master branch, and any features are created, or all the features are iterated on branches from master. So master is always stable. If you look at it from a perspective of how we track the versions of the platforms that we deployed. So if we have dev, stage, and prod, dev is always tracking master. The branches here are tested. So in this case, we have an open pull request and a GitLab runner or some CI job that's run to validate that whatever we built works. And then we have commits that are laid on top of that. And sometimes, depending on how you set this up, if you have tests run per commit, you could continue to iterate on the pull request or merge request and run the unit tests until it's good. Once it's good, you have your fellow engineers to do the code review, making sure that you're not working in a vacuum, to give you feedback, to give you constructive criticism, to help you update your engineering skills and your development skills to make the code the best that it could be. Once that's ready, it's merged back into master and so forth. I'm not going to get into the release engineering process, but at the end of every sprint, we have a release candidate, and then we walk out changes to staging, and then we cut a tagged version of that repo at that point in time. So we have a stable version of the code base that we then deploy to production. So that was the conclusion of the presentation that I had. So at this point, if you have any questions, I'm open to take them. Any sort of commentary about what your team is doing, or any initiatives related to deployment of Kubernetes, or anything that you guys might be interested in. Someone mentioned Istio. So if there's any other feedback that you'd like to provide about what the next topics are to be discussed, that would be also awesome to hear. So any other questions that you guys have, or any discussion points that you think are relevant to share with all of our peers here, that'd be great to hear.
All right, Anthony, we have a few people.
Cool. Yeah, I'm on it. Yeah, I see him. So, okay. So I think Fuik Nguyen.
Yeah, that's me. I know you mentioned earlier, or one of the people on the attendees talked about Ansible. When I was looking at one of your slides deck, Anthony,
Yeah.
I noticed that you guys mentioned about like scheduling. I'm not sure if you're familiar or any of these people are familiar that Ansible is pretty good at it. When you write a playbook, it allows you to do some scheduling automation. Are you familiar with that?
Yeah, so I've used Ansible I wrote playbooks to bootstrap Kubernetes clusters in the past, where I had like Raspberry Pis, had the IP addresses, and was able to basically run a set of scripts on each of those nodes discreetly to bootstrap the cluster. So yeah, Ansible is a great tool. I think it's good that it's imperative. It's agentless, so there's no agents that have to exist on the server. So it just leverages SSH to jump in.
Okay, cool.
Yeah.
Thanks.
I saw there was a few more hand raises.
Right. I saw it from Ian. Oh, there you go.
Hey, so thank you. By the way, great presentation. Really enjoyed the content. Every time I was going to ask a question, I figured you were about to answer it anyway, so I didn't. Regarding Istio, my last client, we use it on GKE.
Okay.
For encryption across the cluster with a certain degree of success, right? Have you had experience running it on EKS?
I have not had experience running on EKS yet. I've run Istio just as a POC in Minikube. So I kind of just bootstrapped the installation of Istio, configured the different components of it. But yeah, so for GKE, I guess you wanted to have, you were able to accomplish mutual TLS for the services.
Yeah, we had mutual TLS running across the cluster. And we also had a simpler setup, so it wasn't as complicated as what you described earlier, but we had a requirement for encryption, and you could just turn it on as part of their Anthos offering. The other thing I would submit is, if you're going to try and Terraform the configuration of Istio, it's not exactly easy.
I think we lost him.
We lost you, man. But thanks for the commentary.
No, I was finishing up with that. I just want to know if you ran it in EKS, and then, I just wanted to share that, if you try and Terraform Istio on GK, it's, well, probably anywhere. It's not easy, but, it's doable. Thanks.
So Ian, how did you guys get that in configuration? Was it just like Kubernetes manifest files, or how did you guys?
Oh, no, we did Terraform. No, so.
Oh, gotcha. Okay.
We did Terraform it with a lot of grafts, but like it was sort of a lot of trial and error, but we were able to do it. It was very important that we were able to recreate environments constantly, because we were dealing with preview environments, and we didn't want a situation where lower environments were not encrypted. We were dealing with a lot of MPI on every level. They hadn't segregated their data, so you had potential for MPI, PII, where developers shouldn't be seeing it. But so we encrypted everything across every cluster, every environment, but ended up working really well eventually. So I want to try it on EKS next.
Gotcha. Yeah, the reference architecture diagram that I showed earlier was leveraging Console Connect and Envoy as edge proxies. So similar service mesh topology, different tool. So Istio is something that definitely want to spend more time in doing. And generally our take on the Terraform, so it's kind of like managing services that are deployed on Kubernetes with Terraform. So from the Kubernetes provider for a little while was very unstable, at least in our experience using it with EKS. So there was kind of a decision that we had to make where, and I kind of mentioned this earlier, like the lifecycle that the Terraform or infrastructure as code lifecycle versus the Kubernetes lifecycle or Kubernetes object lifecycle, to draw like some distinction there, where if we have the stable cluster up, and then after the fact, if we wanted to deploy and configure resources onto Kubernetes, that could be like a different set of actions. And I don't know if Matthew kind of worked with me on and had discussions about that. If you wanted to chime in on the distinction between the Terraform Kubernetes managed resources versus just using Kubernetes native tools.
Yeah. So at least from our experience, we wanted to leverage Helm. So like Helm charts that we had. And I do remember that at the time, like the Helm provider for Kubernetes for Terraform, like it was horrible. So we decided to leverage Helm and Helmsman just to kind of automate the deployment or group up, the various services that we had defined in our Helm charts. And we made the decision to just kind of include like the baseline Kubernetes resources that we need in Terraform. So things like service accounts and like roles for like Tiller, it was Helm 2 at the time, as well as just kind of configuring like the auth config map and just providing the necessary permissions and access that would be needed for the cluster. And then we just decided to have everything else be defined via like Helm.
No, that totally makes sense. I mean, the sort of separation of concerns that you talked about earlier absolutely made sense, and it's something that I recommend to everybody I come across.
Cool. Awesome. I'll move on to James's question. He's raising his hand.
Yeah, so my question is, if we're using a managed service like EKS, how do we allow our Kubernetes resources to authenticate and get IAM permissions to access AWS resources?
Oh man, Matt, you want to help me out that one?
Yeah, I can
answer it better than I. Yeah.
Yeah, so there are a couple different ways, right? In my experience, I've kind of played around with kube to IAM before. So basically, it's like a service that runs in your cluster that kind of stands in the middle of everything. And basically, when your services hit it, they're given like temporary creds to access whatever AWS resource you'd like. But I do know that there is like a native AWS, I guess, IAM service that basically allows you to get IAM permissions at the pod level. I don't know the name of it, but I think that's basically what you would use if you want to get really granular. Or else, if you really didn't care too much, you could definitely leverage like, you could put like a EC2 instance profile, and then give it whatever permissions it needs, and just give that to the EKS worker nodes. But I know a lot of people want to get more granular than that, so.
Yeah, thanks a lot, Matt. That cleared up my question.
Cool. Any other
Awesome.
questions?
There was, if nobody has any more questions, there was like another just item that I wanted to share with everybody. There's a document, if you Google NIST 800-190, this was a standards document that was published in 2017, I believe. Maybe it's somewhere, September 2017, by the National Institute of Standards and Technology. And it's only about 50 pages, so it's not terribly long. But it basically wants to describe what domains that we want to secure when developing containers and orchestration platforms. So it provides a really high level overview of what containers are, and this is probably very common knowledge at this point for people that are using containers. However, I think the breakdown that they have here is good for maybe if you're trying to work with security teams or operations teams that are trying to gain more maturity in containers, and generally how to secure it and operationalize it. There's a lot of good content in here. So it talks about image vulnerabilities, registry, orchestrator, container, all of these components or layers that exist when you're deploying and operationalizing containers. I think this is a great article that I tend to come back to, and that has been a point of discussion when we work with our clients that are operationalizing containers, specifically security teams, on how they can integrate some of these, how to reduce the risk and reduce the attack surface area for their application and container deployments. So as I mentioned earlier, we use the CI/CD workflow, CI/CD1, CD2 workflow as a loose framework of the different states of evolution of a container application as it goes from applications like shift left from developer workstation to a deployment of it as a running container. What are the places that or gates that we can put in place to make sure when we're progressing the code or the containers through this workflow, how do we identify what gates to place, what level of security that we have on each gate, and really just what gates to entertain or make sense to entertain. So I thought this would be very useful to share. I'll just go to the top again. It's a free document, and it's called, if you just Google NIST 800-190, this could be a good start if you're looking to determine if it's viable for containers or just generally to enhance the security that you have in place.
Awesome. Was there anything else you wanted to add, Anthony, or was there any other questions? All right, so I guess it's time to wrap it up. Well, thank you everybody for joining in on today's virtual session. Hopefully it was very insightful. We plan on scheduling the next session on April 30th, and we're thinking about doing it around the same time. Let me know if this is a good time for you. You can comment in the chat. We thought to just schedule around noon because that's a great time for folks to sit down, perhaps take a lunch break, and then join in on a virtual session. Just to let you all know, if you are joining us for the first time, I will be sending out a recap email with Anthony's slides. And this video is live streamed to YouTube. So if you wanted to rewatch the video, you can see the recording on our YouTube channel. So if you just type in Nebulaworks, you can find this recording on our YouTube channel. And then something else I wanted to mention is that we will be sending out a survey at the end of this session, just to get your feedback on what you liked about the session. And then we'll go ahead and also send a link to our newsletter. So if you wanted to get the updated content, that link will be accessible to you in the survey that we sent out. And then lastly, I did wanted to announce, and I think some of you will be very happy about this announcement. Some of you have reached out to me and asked if we will be creating a workspace Slack channel for the Cloudnatives community. Yes, we just launched that yesterday. So now we can basically communicate on Slack, and if you have any other questions, you can ask me on Slack. I will be including a link in the recap email tomorrow, so you can go ahead and join via that link. Other than that, was there any other questions or comments before we end this session? All right, so I guess that's it. Well, thank you, everybody. Well, I hope you have a fantastic rest of your day, and please take care of yourself, be safe and sound, and I'll catch you at our April session. Thank you so much.
Thanks, everybody. Stay safe.
Thanks.